Good day, favorites. Welcome back to another episode. Okay, I have a question on the board. It's a very beautiful question. Don't forget, we are still on friction and then I'm taking questions. So feel free to inbox your question. All right, look at this diagram. I try to make it beautiful, but then we will just manage this one. All right, two bodies, X and Y, of masses 5.0 kg and 7.5 kg. You can see X and Y, respectively, are connected by a light inextinguishable spring as illustrated above. If X is placed on a rough surface, the coefficient of friction, rough surface of coefficient of friction 0.5, calculate the magnitude of the Roman figure 1, normal reaction on X, Roman figure 2, frictional force between X and the surface. Then Roman figure 3, tension on the spring. And of course, G, acceleration to gravity as in 10 meters per second square. Okay, this is a very simple question. No panic. You see this thing in your exam, just laugh. Simple question. Okay, first let us try to evaluate. We are looking for normal reaction on what? On X. Normal reaction on X. Okay, remember our diagram. We talk about friction. Now this is X. We have this like this. This is the weight. This is the what? The reaction. Why this is the what? The force tending to cause motion. Why this is the frictional force. We are looking for normal reaction on what? X. The normal reaction on X is equals to the what? Weight. So therefore, I can say that the reaction on X is equals to the what? The weight. And weight is what? Mg. So therefore, normal reaction, let me say Roman figure 1 is equals to, what's the mass? 5.0 times what? G. G is what? 10 meter per second square. The normal reaction is what? 50 Newton. Very simple. Roman figure 2, frictional force between X on the what? Surface. We are here. Frictional force between what? X on the what? Surface. So we are looking for the frictional force. And don't forget, we're giving what? Coefficient of what? Friction. Mu. Roman figure 2. So we're giving coefficient of friction as what? 0.5. Remember, this coefficient of friction is dimensionless. For we to get the frictional force when we're giving coefficient of friction, it's very easy. Remember this formula. Remember this formula. The frictional force is equals to what? That is the coefficient of what? Static friction. And the product of coefficient of static times what? Normal reaction. Remember this formula. Don't act as if you don't know this one. You don't do one before. This formula. This is the formula we use. So therefore, the frictional force that is equals to what? Mu what? R. So this is equals to mu is what? 0.5 times what? The reaction, which is what? 50. So the frictional force is what? 25 Newton. Very simple. Now, tension in the spring. Tension in the spring. Now, what is causing tension in the spring? Is this idiot, this one here. Why? That is what is causing tension in the spring. And tension is a force. So the tension in the spring is the what? The weight of what? Y. So the tension in the spring is equals to what? The weight of what? Y. Let me put it. W subscript Y. That's what the tension in the what? Spring. This is Roman figure 3. Equals to weight in Y. So therefore, weight is what? Mg. What's the mass? Mass there is what? 7.5 times what? G is what? 10 Newton. Which is equals to what? 75 Newton. So this is the what? Tension in the what? Spring. We have come to the end of this episode. Please subscribe to my YouTube channel. It's very easy to subscribe. You don't need to panic. Just go to my bio, click on it, and then you are there. And subscribe. Very simple and very easy. Simple as ABC. There you have so much elaboration of what mathematics and what physics, including further maths. I have loads of questions in further maths that I need to evaluate. Please make sure you are there.